This lesson we're going to talk about multiplying and dividing the rational expressions. So rational expressions is same as fraction. It's just that you have a variable everywhere, right? So we're going to use the same method. That means we're going to simplify it before we're going to multiply. In order to simplify it, we need to know if we have a common factor to get rid of comparing between numerator and denominator. So in order to find that common factor, we need to write all the expression into the factor form. Look like your first fractions. Numerator, you cannot factor any further, so you're going to see that whole thing as the one factor. Denominator, you cannot factor any further, but it is 6 times x, so you have to factor on that one. Times, let's see if we can factor the second fractions. Numerator will stay same. It's 2 times x cubed. Denominator, look like this is going to be difference of square. Since we can rewrite this into x squared minus 1 squared, right? Difference of square. So you should be able to factor it as x minus 1 and x plus 1. Once it's all factor form, once it's all multiplication form, you can cancel out the same or common factor, numerator versus denominator. Then you multiply numerator by numerator, what's left over, and denominator by denominator. I also see that 2 goes into 6 3 times. 1x, cancel out 3x, and you will have only 2x remaining. So look like you have numerator 1 times x squared. That's what you have on the numerator. Denominator, you have 3 times 1 times x plus 1. And you can leave your solution in a factor form. Let's look at the next problems. So we're going to go through the same thing. We wanted to see if we can rewrite this problem into the factor form. Look like the numerator, I have a common factor 4, x minus 2 remains. Denominator, common factor x. Then I will have x plus 1 remains. This is another difference of square on the numerator of the second fractions, right? So this is another difference of square since you can rewrite 1 into 1 square. So when you factor that, you get x plus 1, x minus 1. Denominator, common factor 3, you have x plus 2 remains. So then you're going to get rid of the common factor. Numerator versus denominator, look like x minus 1 on the numerator, x plus 1 on denominator, cancel out each other. And what else? I don't see anything else, right? So what's left over? I have 4 times x minus 2 times x minus 1 on the numerator. Denominator is 3 times x plus 2 remains. One more with the multiplications, right? So basically that's what you're doing. One more multiplications. Factor first, right? Trinomial factoring, remember, right? So trinomial factoring. X times x is going to be x squared. Same sign. That same sign must be negative. 1 times 1. Look like that's perfect square, right? You have common factor x, then you have x squared plus 1 remains. This cannot be difference of square because this is additions, right? And then the other numerator, you have common factor 4, and you get x squared plus 1. Denominator, factoring trinomial, you're going to get x times x squared, different sign, and one is positive, one is negative. Larger number should be positive. Once it's all factor form, let's see what we can get rid of. This 2 can get rid of. This 2 become 1. Nothing else. So numerator you have 4 times x minus 1. Denominator you have x times x plus 2. Don't forget, since they didn't mention what form of the solution they wanted, you can leave your solution in a factor form. Example 2, we're going to look at the division this time. So there are a few different ways of working these problems. But today, in this sections, we're just going to making sure we understand this division right here is same thing as dividing numerator versus denominator, right? Once you realize that, you can just pretty much rewrite this problem with division sign so that it's not going to be complex fractions. Complex fraction means you have fraction inside fractions. So this divisions, same thing as fractions with the number, right? Change to multiplication, flip the second fractions. Maybe at the same time I can factor it, right? So that I don't have to keep writing the same thing over and over. So your denominator will become numerator because I'm flipping this because I changed division to multiplication. So denominator become numerator, and this is another difference of square because 1 can be 1 square, right? So when I factor this, I will get x minus 1, x plus 1. Denominator, 3x squared become denominator, and it's already multiplication form, so you don't need to do anything with it. Let's see if we have a common factor. So x plus 1, 3 goes into 6 2 times. X cancel out, gives you only 1 x remaining on denominator. So numerator, you have 2 times x minus 1 remains. Denominator is just x, right? So once you change to divisions, once you realize this division problem, change to multiplication, flip the second fractions, and then do as the multiplication that we did on the exam 2. Example 1. So this one is same as x plus 3 over, if you want to, you can change this into factor form here when you're rewriting it. This is same as x squared minus 2 squared, right? So when you factor that, you get x minus 2, x plus 2. Dividing by, factor the numerator, you're going to get x minus 4, x plus 3. Denominator is difference of cube. If you don't remember, you can look for the formula online. Or from the previous sections, right? And when you factor this, you're going to get x minus 2 times x squared plus 2x plus 4. But don't forget, in order to do any canceling out, you need to change to multiplications and flip the second fractions only. Let's see what we can cancel out. Look like we have x minus 2 and then x plus 3, right? Then what's left over? The numerator, I only have trinomial left. Denominator, I have x plus 2, x minus 4. If the numerator is factorable, we should be factoring this and see if we have any comments with the denominator. But this is not factorable because factor of 4 give you addition of 2, there is none, right? And had to have same sign, right? So you cannot factor the numerator, so you cannot find the common factor. But if it's a factorable, you should factor it and then get rid of common factor if you do have one. Let's try one more. So this one, C. What we need to do is we have not only divisions, right? We not only have a divisions, we have multiplications too. So what I like to do is when I'm writing these multiplications, I'm going to write it with the factor form if I can factor. 6x squared will stay same. But then the second fractions, numerator, I can factor 4 out. Let me write that down for you. So when you factor 4 out, you have x squared minus 1, which that is difference of square. So if you factor further, you could do x minus 1, x plus 1. Over 9, you cannot do anything. This denominator, however, is difference of cube, because this 1, we can write it as 1 cube. So when we factor that, that's going to be x minus 1 times x squared plus x plus 1 over your denominator. Your denominator is also factorable. Look like I have a greatest common factor, x. And I will have 4x squared plus 7x minus 2. Denominator, common factor 3. I have x squared plus x plus 1. So right now I wanted to, this is a big problem, right? So right now I wanted to just focusing on my multiplications to see if I can reduce, right? Because like I said, it looked really big. So let's see, look like I have common factor x minus 1 and 3 goes into 6 twice, 3 goes into 9 3 times. So when you rewrite this, the numerator, I will have 2 times 4 is 8. X squared and x plus 1. Denominator, I will have 3 times x squared plus x plus 1. And this is divisions, right? So I have to put divisions with this number right here on denominator. change it to multiplications. And flip the second fractions. And this factor, this trinomial, I will not factor it. And I don't think it's factorable. But the numerator become denominator because I flipped it. I will factor it. And look like I will get 4x minus 1, x plus 2. And let's see if you can get rid of the common factor at this point. 3 and 3 cancels out. This trinomial, big trinomial cancel out. So if you want to, just cancel out. Get rid of it. X, cancel out x squared, give you only 1x. So far what do we have? If you end up leaving some common factor, you can get rid of it through more than one times. But I think I get rid of all. Let me see what I have remains. On the numerator, this is what I have. Denominator, I have 4x minus 1 times x plus 2. And I don't see any other comments. So that must be my solution for that big problem.